Ahoy Captain, and welcome to the First Aid for a Sustainable Ship series, in which we give guidance on decarbonizing your vessel. And in this video we'll look into an inland waterway vessel plus solar PV, as you can see here. So this is going to be a case study in which we apply solar PV panels, in this case flexible solar PV panels, on top of the cargo hatches in order to provide energy while moored. So this won't be for sailing applications, we'll simply look at the vessel while it's moored. So this case study we're gonna call the Sunny Sailor for an inland waterway vessel, and we see about 26 to 100% carbon reduction depending on the time of the year and of course the amount of solar panels. The capex investment are roughly 150k for this case study, and we're gonna look into the dependencies and the assumptions later. It's gonna give a payback rate of about 5+ years. It's hard to say because it really depends on the factors that we are going to assess, but at any rate you could assume in North-Westhern Europe it's about twice as expensive and thus takes twice as long as regular house, garden and kitchen solar PV. And finally we have made this case study together with Wattlab, a great partner or supplier of solar PV panels, flexible panels, and they've also helped us to assess some of the costs, dependencies, technical assumptions, etc. So it's based on some of the experience that they also have in the field with inland waterway vessels. I want to thank them very much for it. That being said, we have two parts of this video, so please feel free to skip ahead to the fun stuff. We have the online tool that is free to use, so that we're gonna fill in together with you, and then we have the premium report part. The first part we're gonna talk a little bit about the input and assumptions that we have, so that you can see which assumptions we use and whether or not they apply to your vessel as well. And then finally we're gonna go more into detail in the results and discussion phase. Now I have to admit that premium report usually costs 399 euros, and for this case study you're gonna get an in-depth view on what you will get. So that's also nice to have, especially if you already have an inland vessel. That might mean that you don't need to pay for the premium report, but we'll see. First, a few disclaimers, because while the decarbonizer is but a model, we make assumptions, we make a lot of them, so we really need to make sure that they apply to your vessel as well. And being a model, you could say that we are at a feasibility concept design stage. So it's not a technical or detailed design, though we are getting close in some regards. It's mostly a way to model your sustainability strategy, especially in the long run, which rules and regulations will apply, the amount of carbon reduction you need for your vessel, etc. Please keep that in mind. Secondly, it's constantly evolving. That means that the version that you see in this video might actually be different than the version that is online or in the premium report, should you choose to use one. Thirdly, well, you see a human sitting in front of you. It's made by humans, and unfortunately we make small errors as well. Let us be inspired by Bob Ross, meaning that the small errors we see also as beautiful and as a way to learn, especially. I mean, there's no going around it. This whole sustainability thing, it's an iterative process, especially for your vessel, and we're learning as we go. So bear with us, and if you see any mistakes or you feel we do something wrong, feel free to contact us and give some feedback. And then finally, even though this is made by the help of Wattlab, we've used quite some of their experience and knowledge. We are independent, as in we don't get any money for it from Wattlab. We honestly believe this is very good technology. Wattlab is a great supplier, and on a personal note, I truly believe that solar PV or solar panels on board your vessel or having them floating next to your vessel is one of the best and easiest way to reduce your carbon emission, in particular if you're idle and moored, which is why we're looking into this case. All the disclaimers are now out of the way. Let's dive into the first part, the online tool part. And as you can see, I have provided here a link, and we're going to click on it to see where we get. So here we have the decarbonizer tool, and I'm gonna admit this is actually a special version for the Sunny Sailor in particular. If you go to the link that was just shown, you'll see the entire tool, but I'm gonna walk you through it so you have more, so it's gonna be easier for you to fill in. So here we have our vessel, the Sunny Sailor. It's an inland waterways type, and we have 3 options at the top: ship and operational profile, rules and regulations, and carbon reduction and solar PV technology. So here we see our representative power demand. While idling or moored, we have about 26 kilowatt average power required, and this is again only for the idle moored scenario. In case we're going to look at a combination of idle, moored and sailing, then we get a representative profile, yearly profile, that you can see here, in which case also the power consumption is a lot higher when sailing and it's quite low when idle or moored. Each case is different, and I'm going to talk a little bit more about the operational profile later, but we're going to view idle moored in this case in particular because solar PV is so well adapted for that particular case. And here we see the fuel, carbon emissions, the running cost, the day rate or the OPEX per day, and the CO2 emissions that are a part of these OPEX costs, and you can do it per day or per year. What we usually do with our customers is that we, here we see one of the errors. This should not be 333 liters, it should be a lot more than that. So I'm gonna look into it later. But here, this is usually the amount of fuel and carbon that we try to get as close to as reality for the ship owner to get a representative power demand for the vessel. And in the OPEX breakdown, we also see more physical parameters that we try to narrow down as much as possible, all the emissions that we have, and of course the costs. These are an estimate that we also get as close as possible. And here we see the amount that it should be per year. So we have about 700 euros per year and 250,000 euros running costs per year for this particular vessel, the Sunny Sailor. And here we have the vessel and ship the ship and fuel parameters. What's there to say? Well, we have a large Rhine vessel taken as a base case, which is 110 meters long and 11 meters wide. That's important for our solar panels and the hatch itself. The gross tonnage will give us something to tell about the rules and regulations that apply. Cruising speed, similar. It's running on diesel, marine diesel oil. Current fuel price, quite high actually. I think in Rotterdam you can get a little bit less for your fuel, but this is what I see in practice in a lot of other places as well. EU ETS cost, I've included them for now, but here you can easily exclude them, as in the coming few years they won't be included, but I'll just keep them here because in the long term we're definitely gonna have to pay these, well, we'll probably have to pay these, who knows, in the long. And we see our auxiliary power is about 102 kilowatts effectively. Probably 2 engines here, 2 engines of what's going to be 60-65 kVA, 2 generators, I have to say. So this is our assumed power while idle moored. Assume maximum available power while idling or moored. This you can adjust, not just in the ship and fuel parameters, but also here in power demand. So assuming 365 days a year of idling, then we have, let's make it 35. We can increase the power consumption so it accommodates your particular needs, and that will also influence the costs in the end. But we're gonna stick to 26 at the moment. Well, it's actually 25 on something, but that's fine. As you can see, this is an interactive tool. We use this, well, it's a tool, it's a model. We use this to narrow down and get in the order of magnitude of costs. Engine characteristics, very important, and usually this is very hard to pin down as well, but as you can see here, this is our specific fuel consumption curve, and usually for most marine engines we see about an optimum at about 180 grams per kilowatt hour, between 80 and 85% each of continuous load. And in this particular case, considering we have 100 kilowatts installed, we're gonna be in this area, so around 220 grams per kilowatt hour. We can adjust them here. 4-stroke, 2-stroke. 2-stroke will actually reduce it a little bit, should reduce it a little bit. And if we increase engine speed to high, then we see also fuel consumption is increased. But we're gonna stick with 4-stroke medium. There we go. And that's then the specific fuel consumption that we have. All right, so that's it for the ship and power and operational profile. So normally we try to fill this in as much as possible. In the premium version, we can actually fill in a lot more to even get it more accurately. But let's move on to rules and regulations. And I have to admit here, this is not really an error from our side. We have not included all the rules and regulations from inland vessels. Here we see the IMO, which is for most vessels basic reference line for decarbonization, which we start at well, a few percent already this year, and we need to reduce carbon emissions by 70% in 2050. That's their goal. For inland vessels, especially in North-Westhern Europe, or actually everywhere around the world, these rules do not apply, and that applies to CII and EEXI as well, even though EU ETS, that one's probably going to apply at some point in the future. So this target date and target reduction, we're just going to leave it as is, or for what it is, and we're not going to look into it in more detail. And I'll promise you, in the future, once we have more inland vessels accommodated for, we'll include these rules and regulations so that you can get more accurate insights on which rules and regulations apply to you. We do have a few other rules and regulations that might apply to you when you're sailing in North-Western Europe, and we're going to expand on this, hopefully using your feedback as well, but if needed, we're gonna add it to the tool. So going back to our visualization of what solar PV can do for you, normally we have a lot more options. Now we're just gonna look into solar PV, but we have about 10 options at the moment, and we're continuously expanding on technologies and carbon reduction measures. But in the current situation, we have, of course, zero CO2 reduction. We don't have to pay anything, we have a fixed day rate, and we don't have any payback. But if we apply solar PV panels for this case, we have 45% reduction of carbon emissions and fuel. We do have about 177,000 euros in investment, which is a lot. And we also have only 100 euros per day estimate of reduction in OPEX, which leaves us in a payback which is, well, calculating, that's well ahead of 6-7 years. Let's see if we can get it better. Here I have different visualizations available. So 1, 2, 3, 4, 5, 6, 7-ish years. Yeah, it's not great, it's not terrible. I think that one of the beauties of this technology is that it could make you shore power ready, but I'll get back to it later. Going back to the numbers, here you see that this is really sensitive to surface area, time of the year, and of course the cost, capex cost of the system, which we usually divide in the capex cost per kilowatt. We have now assumed a surface area of 251 square meters, which is roughly the area you can cover with the hatches. So we're gonna leave that one, but if you have a different vessel, different options, you can easily change this. Let's do it just for fun, see how it changes our payback rate. Let's see, 350, so that's gonna not do much for a carbon reduction, gonna greatly increase capex, won't do much for OPEX either, and I think I know why, because that mostly has to do with the day and time of the year, and the fact that we don't have a battery installed. I'll also come back to that later. So this is for March, and if we're going to do June, then probably we're going to have bigger CO2 reduction. There we go, 62%, still the same capex, should be fine, but still not much more reduction in emissions. So that's a pity. We're going to come back later to see how that all works, and of course if we change solar panel costs, that's now 500. This is a gross estimate, I should say. We're going to narrow that down in the future even further for you, so you get a better feel of how much these panels would cost you. But all in all, you could take into account that the average price for solar panels is about twice as much as land panels, at least in North-Western Europe. But changing this one, it's twice as cheap. Yeah, we have a great dealer of solar panels. You see that influences it some, but there are also other components involved which can be changed in the premium version, which we're gonna do. Fuel parameters for this model are a bit less relevant because, well, we can change, of course, the fuel price, and then our OPEX, and, well, in both cases increases. But this is most relevant when we have different options of fuel available for decarbonization measures, and then we can change them better. So this we're going to leave as is. The OPEX breakdown, here we have the current and the after measures, and as you can see, we greatly reduce the amount of energy required, the average power, thereby reducing fuel consumptions and also engine hours. Instead of 24, we only have 10 engine hours running. However, there's a caveat there. Usually you need to include a battery system in order to accommodate, for example, sudden drops of power for your solar PV installation when the clouds, this is a cloud, when clouds suddenly pass over your vessel. And that's not included in this model. It's something we're working on as well, but again, take this with a grain of salt, because the intricacies of not having a battery system and making sure that your solar PV panels are able to provide a grid for your hotel load on board your vessel, well, that's a tough one. That's a tough cookie, and that's also why we talk with suppliers such as Wattlab, because they have the knowledge and they can provide you with more information on that particular subject for your vessel. Again, the fuel reduction and energy reduction should correlate nicely with the emission reduction, and there we have also a cost reduction factor as well. Okey-doke. That's about it. So you have 16-17% OPEX reduction per day and thus per year as well. The CAPEX breakdown, very important to see what exactly you're paying for, and as you can see here, most of it is just equipment cost. You're going to have the PV system and applying it to your vessel depending on what kind of vessel you have and how much time you need to spend on really hooking it up to your board net is that's of course differs per vessel. Let me show you later how we accommodate that as well in our tooling. But for all intents and purposes, these scenarios, most of the costs will be simply the equipment cost. And that concludes how we fill it in. As you can see, just simply go through the entire model from ship and operational profile, which you fill in, rules and regulations. That gives you an idea on the amount of CO2 reduction that you need to comply with. This of course is more for international travels and not for inland waterways. We're gonna work on that. And then finally we have our CO2 reduction measures and solar PV in this particular case, which you can also change. Now we're going to move on to the fun part, actually the reporting, the premium reporting, the results and the conclusions that we derive when applying solar PV to an inland waterway vessel. Let's move on. So part 2, the premium reporting. I'm just going to quickly brush myself aside so you can see the link here. I'm going to click on it and I'm going to show you the link where we have all this information contained, and then I'll show you something that's a bit of a secret. So here we have the website where you can find all the information discussed in this video. I'm going to quickly put myself back on top, bottom. Things are going great. So here we have all the information that you need, the report. Cancel. This is actually the report that we're going to discuss. It's a premium report that includes all the information, including the different sailing profiles, rules and regulations, the carbon reduction measures, the full table, as well as the technical details of the technology. But I'm going to show you the back end. So here we have the back end of the report that you just saw, and this is the back end tool that we go through when you pay for the premium reporting, and this one has all the different parameters that you can adjust, and we tweak it until you are satisfied in the 1 hour consult that you get. So the final summary here that we have on the Sunny Sailor for idle and moored situations is that we have well, we've seen the results, approximately 167 liters of fuel per day, 500 kilograms or half a ton of CO2 emissions, and then finally a €700 per day costs. And in this particular case we have 45% reduction of CO2, and that is the case when we are moored in roughly April. Now I'd say April, well, beginning of April. It's March. If we change to, let's see, June, as you saw, then it's gonna go up to 62% reduction while still leaving capex, etc. the same. We're gonna go into detail a little later to see how we calculate it. So here we have the table of contents. So we're gonna quickly brush through them. The disclaimers you have already seen. The main operational profile and vessel parameters of the Sunny Sailor. Here we go. And this is of course the things that we adjust when we talk with you about your particular vessel profile. The different percentages of operational profiles. So it's 100% or 365 days idle and moored. That's of course not really the case, but we're gonna only see how it would look like in that particular scenario. The current OPEX of the Sunny Sailor with a breakdown. The yearly combination of profiles and the idle moored profile. In this case we only have idle moored, but yeah, let's see. If we change the operational profiles to a combination, there we go. Then we have a different setting of our reporting. So we have the sailing, and that is with respect to the maximum installed power on board your vessel. And as you can see, your idle moored load is a lot less than what you normally use for while your vessel is sailing. But we're gonna go back to idle moored. There we go. Pops back. That's great. Rules and regulations. What can we say? Well, for inland vessels, we're going to definitely look into more detail on the different rules and regulations. But for now, most important one coming up, or might not be coming up, is EU ETS. That's only included for now for vessels of 5,000, for 5,000 GT, and it's going to go to 400 GT plus in the future, probably. But for inland vessels, I'm not so sure. So that's the only thing, and even so, it's 14,000 euros. It's quite a lot per year, but it's man, this is only while moored, by the way. Then we have our carbon reduction and cost. I'm gonna scroll a few. I'm gonna enlarge it a little. We only have solar PV applied. Actually, for normal decarbonizers, we can have a shore power technology, a prevention technology, and then a different fuel change for your vessel. But for now, we're gonna look into solar PV only. Like I said, it's up to 63% in summer, but that has to do with the fact that we don't have a battery pack installed. So let's go to the funnest part of all. Here we see the technical details of solar PV, and I'm going to zoom out again to get a better picture. Maybe I'll zoom back into the table itself. The Sunny Sailor in this case has just simply solar panels covering the entire hatch. So these hatches are removed when, of course, you need to unload or whatever, and that you have to do manually. It takes some time, but from what we hear, it weighs up the costs of time way up to the benefits. And even while sailing, you do get some benefits, but if you're not a diesel or electric but a direct drive vessel, then you need to be able to accommodate the power for your onboard grid. But this is the case that we are looking into, and here we see the operational profile and how we calculate it. We have the regular operational profile, and when the sun is coming up and providing a lot of energy, and this is the amount of power that the solar installation will provide. But as you can see, the installation itself is a lot more than what the ship needs. So in this case, all this excess power goes to waste. So what we would need is a battery pack to store the additional energy for the night, and then we have a continuous operating profile with solar powered panels only. And as you can see, well, this is 4:30 again in the morning. That's really early because it's June, the longest day of the year. But if we're gonna go back to the other extreme, which is December, there we go, then it's only gonna be able to, well, roughly provide enough energy during the day, and it's gonna make a very big impact on not just our cost but the entire energy system, of course. In this case, probably it won't be enough to power your vessel throughout the day, or you need to greatly increase the amount of solar panels, which is, well, there's a practical limit to it. Usually we have March as our base case. This is the average, should be the average roughly per year, and even in the average you see that solar energy is abundant and available, but you need to cover your entire vessel naturally with. So in the future we're going to expand on this technology by providing you with a battery pack that you can attach, and then you can see what cost impact would be. The greatest benefit of this particular technology is that it will make you comply with AFIR and EU ETS. As far as we can tell, shore power will become mandatory for the EU by 2030 in most places, most ports. About 90% of all port calls need to be electrified. This technology, in particular in combination with the battery pack, will make you accommodate shore power. Will make you have shore power anywhere you go when you're idling on board. Of course, it's going to be tricky in the winter times. Then you might need to either use onshore power supply or simply your generator from time to time. That's something we cannot say at the moment, but solar panels in that sense will be really easy for you while idling on board. You simply well, they're always on, so it's nothing you need to do about that. We have more case studies for vessels, also for floating solar, and other case studies where even energy majors are well, flirting with the technology. So you can, in this decarbonizing report, and also of course on the website, you can click through them and you can have a look at what others are doing as well to get either inspired or learn more about the technology. For the Sunny Sailor in particular, where we are now, we have about 20% covered. 20%. We get a surface area of about 250 meters. This is of course a very important parameter to make sure that it's correct, because together with the cost and the total power production, it's one of the basics for the getting an estimate of what you can do. So how do we calculate it? We have an average of 375 watt peaks per square meter solar panel efficiency. It's quite a lot. we can change it if needed. We include system and solar efficiency losses for the entire system due to environmental aspects, like not the wind that should not impact the design itself, but clouds, temperatures, inverter losses, etc. These are all included. And then we derive a peak power of the total installation, and that provides us with an average energy profile per day, per year as well. And with that included in costs, we derive an OPEX. With a lifetime, we derive at a total life cycle capex and OPEX in order to get an estimate of the costs per kilowatt hour. And well, we can change this. Well, we can change these almost 20 parameters for a long time. So we'll guide you through it, talk you through it, and see what applies best to your situation. Because in the end, it's all about the costs. Well, I'm really kidding. It's always about the costs, because those are the best way to see what the entire system will do. Here we have the same graph that we just saw in the tool itself. So we always break down into 6 different aspects, most of which are simply time costs, design engineering, execution, commissioning, and class. And equipment and procuring costs, those are in this case also the biggest cost always. It really depends on the supplier that you're talking to, how they provide you with a quote or how they break it down. We might do it differently than what you are used to or what our other suppliers do. They might give you a lump sum, for instance. That's something that we see as well, but well, we simply break everything down into these elements because these apply to almost any decarbonization measures, even when there are zeros. And we have a more detailed table here, and well, as you can see, the detail in this table is not a lot because, well, the system itself in this case is, I'd say, quite simple and elegant. You simply have your solar panels, your inverters, and your cabling, and it's really up to the ship owner at this point, because we cannot, without any general arrangement drawings or more specific drawings, tell you anything about the costs and the cable lengths themselves. So this is an estimate. For other technologies it's going to be a bit more detailed, but for a solar PV this is the best estimate we can give you with the input that we have at the moment. Moving on, we have the OPEX breakdown for the current and future Sunny Sailor. This we discussed a little bit as well. Here you see the engine hours are still fully included, even though they could be turned off, but in this scenario we cannot say for certain that engine hours can be fully reduced, because probably the solar PV panels alone will not be able to provide an onboard grid, steady onboard grid. So in that case, a battery pack needs to be added. That's going to incur more costs, etc., etc. We're working on that, but for now you can also see that if you have half your engine hours on, that's also going to save you a lot of money. And in general, what we see is that a lot of savings for fuel and carbon emissions for different carbon reduction technologies is due to the reduction of engine hour. That's some of the things that most ship owners don't really take into account when making these business cases. And here we have the contact details for our supplier that we work with, and I just want to quickly send my regards to Sarah for helping us out with a lot of the details that you see in this video and this document. Again, I want to state that it's constantly evolving, so by the time that you see this movie, things will have changed and be different, but still the basics of how solar PV will apply to your vessel will apply. That's simple physics. The rest of the report itself is mostly a listing of assumptions in the appendix, etc. And in this case, because CII and EXI are not applicable to inland vessels, that does not apply to this particular case. And that's it. Now moving back and wrapping it up. That's it for our inland waterways vessel, the Sunny Sailor. We've seen a very big carbon reduction in the case of idling while moored, 26 to 100%. In some cases, if you really want to, you might need battery technology for that, but we're gonna come back to you on it. You probably need about 100 to 150,000 euros in terms of investment costs, which gives you a pretty high payback rate for most ship owners, at least in the order of a few years. Still, for some that's great, for others it's not enough. But I know for a fact that Wattlab can help you make that business case. So if you're interested, you can contact the help desk to get more information from us, or you can contact Wattlab directly. In any case, we hope that this has provided you with some insights and guidance on how to decarbonize your inland waterway vessels, and we wish you a very great day. It's not wishing, is it? It's very giving. Anyways, have a great day.